Hi there, welcome to Cybersecurity Dojo. My name's Dave, and in today's video, we'll be talking all about the OSI model. We'll explore topics from what the OSI model is, to why it's important to learn, and how the OSI model works. All that and more, coming up. The Open System Interconnection Model, or OSI model for short, is a conceptual framework that was developed by the International Organization for Standardization that shows how network communication works by breaking down the complex process of sending data across the network into 7 distinct layers. Before we cover why this model is important to know, let's briefly take a look at what it actually does. The OSI model simplifies network communication by breaking it down into 7 individual layers, each with their own job. From the physical layer at the bottom, dealing with the bits and the bytes, up to the application layer at the top, which is what you'll interact with directly. Each layer plays a crucial role in ensuring that your data gets to where it needs to go, both reliably and efficiently. Now that we have a basic understanding of what the OSI model is, why is it important to learn? First, it provides an understanding of the terminology used by everyone involved in networking. Whether you're a network engineer, software developer, cybersecurity analyst, or someone who's trying to understand how the internet works, the OSI model gives us a shared vocabulary and a way to talk about network communication without getting confused by the technical jargon. Second, an understanding of how networks communicate is absolutely essential when trying to troubleshoot network-related problems. When you lose your network connection, the OSI model helps us pinpoint where the issue might be. By understanding each layer, we can systematically identify the source of the problem, whether it be a faulty cable, a routing issue, or even a problem with the application itself. Finally, the OSI model is critical for anyone learning about networking, especially those interested in cybersecurity. It's the foundation for understanding more complex networking topics. For cybersecurity practitioners, this foundational knowledge is crucial because it helps you understand how data flows across the network, where vulnerabilities might exist, and how attackers might try to exploit those weaknesses. So having a solid understanding of how the network functions, you'll be more easily able to defend against attacks. So even though it's a conceptual model, the OSI model still has real-world value, as it provides insight into how networks actually work and helps us understand how to more efficiently troubleshoot networking related problems and build better networks. Now that we know what the OSI model is and why it's important to learn, let's go ahead and start diving into what each of the layers does. Let's start at the bottom of the OSI model. Layer 1. The physical layer. This is a layer that deals with physical connections that make networks possible. Think of this as the hardware layer. It's all about cables, wires, and wireless signals that transmit data. It's responsible for converting information into electrical, light, or radio signals that can travel over physical connections. These connections can be anything from the Ethernet cable plugged into your computer to fiber optic cables that carry data over long distances, or even Wi-Fi signals that connect your phone to the internet. The way devices are connected is also part of the physical layer, and this is called the physical topology. Understanding how devices are connected is important for security, as it can affect how easily an attacker might gain access to your network. Finally, physical security is very important at this layer. Protecting the actual hardware, whether it be the cables, servers, or other networking equipment, is a critical part of cybersecurity. If an attacker can gain physical access to your networking equipment, they could potentially cripple your network. In summary, the physical layer is all about the physical aspects of networking. It's the foundation upon which everything else is built, and it's important to consider from a security perspective when it comes to physical access and how devices are connected. Now, let's move on to layer 2, the data link layer. Building onto the foundation of layer 1, the data link layer is responsible for data transmission between directly connected devices. This layer takes the raw signals from the physical layer and organizes them into something called frames. You can think of these as addressed envelopes. They contain both the data that you're sending as well as key information that helps it get to the correct place. This includes the addressing information called the source and destination address, which is like the from and to addresses on an envelope that you're sending in the mail, as well as containing error checking codes, which is really a way to make sure the contents have both been not tampered with nor corrupted in transit. So the data link layer is responsible for getting these data envelopes reliably from one device to another on the same local network, making sure they both arrive to the correct address and are intact. Next, let's talk about layer 3. The network layer. This layer is responsible for getting data between different networks across the internet. Think about it like the postal service. It figures out the best route for your data to traverse the internet and get to its destination. The key here is IP addresses. Every device on a network has a unique IP address, much like a street address on a house. These addresses help routers direct data to the correct destination. And routers are like post offices of the internet. They use IP addresses to figure out where to send the data next. And from a security perspective, basic firewalls also operate at this layer. They're like the security guards at the post office, checking addresses on packages and blocking any suspicious deliveries. These basic firewalls check IP address information and take action based on their configured set of rules, known as an access control list. So layer 3 is all about routing data between networks using IP addresses. It's what makes the internet work. Next, we'll cover layer 4. The transport layer. Continuing with the analogy from layer 3 being the postal service determining the best route, layer 4 is the delivery service ensuring a package arrives at the right apartment within the building. It's responsible for reliable end-to-end delivery of data between applications on different devices. The transport layer handles things like segmentation and reassembly, where it takes large chunks of data from, and a bit of foreshadowing here, Layer 7, the application layer, and breaks them down into smaller segments prior to sending. And on the receiving end, the transport layer then reassembles the segments back into the original data. This layer also deals with connection management. The transport layer can establish connections between applications, ensuring that data is delivered in the correct order and error-free. Now there's two main types of connections: TCP, Transmission Control Protocol, which is reliable, connection-oriented, much like a package with a tracking number. This protocol is mainly focused on reliability, getting you all of the data that you asked for, but isn't particularly concerned with speed. The other connection type is UDP, User Datagram Protocol. This protocol, opposed to TCP, is all about speed, and not necessarily about reliability. You're typically going to see this protocol used when you're doing video streaming, where it sends data as quick as possible without making sure you actually get it, because that would slow it down. If you're ever streaming a video and you notice that the video quality starts to deteriorate or perhaps start buffering, it's either because data is being lost in transit or even arriving out of order. And from a security perspective, the transport layer is extremely important because it deals with ports. You can think of these like apartment numbers. They identify specific applications running on a device, and firewalls will use these ports to control which applications can communicate on the network or to the internet. For example, a firewall might block access to certain ports to protect vulnerable services running on a network. Layer 4, the transport layer, is all about reliable end-to-end delivery of data between applications. It handles segmentation, connection management, and uses ports to identify specific applications. Now, let's talk about layer 5, the session layer. You can think of this as a conversation manager. It's responsible for establishing, managing, and terminating communication sessions between applications. The session layer handles authentication and authorization, where authentication is the process of proving you are who you're claiming to be, and authorization determines what you have access to once you're authenticated. This layer ensures that only authorized users or applications can establish a session. And one of the most important functions is session management. It keeps track of the state of all communication, ensuring that data is exchanged in the correct sequence and that the session is closed properly when it's finished. So the session layer is all about managing the communication sessions between applications, handling authentication and session management. Let's move on to layer 6, the presentation layer. This layer acts like a translator or formatter and is responsible for ensuring that data is presented in a format that applications can understand. This layer handles things like data translation. Different applications may use different data formats, and this layer converts data from one format to another to ensure compatibility. For example, it might convert image files from PNG to JPEG, or text from ASCII to Unicode. This layer also deals with data encryption and decryption, where it encrypts data into unreadable ciphertext before sending, and converts it back into readable plaintext when it reaches its destination to ensure that confidentiality is maintained. This process is critical for secure communication. Lastly, another key function is data compression and decompression. This layer can compress data to reduce its size prior to sending, and then decompress upon receiving it to improve efficiency. So layer 6, the presentation layer, is all about data formatting and security. It handles data translation, encrypting and decrypting, and compression and decompression to ensure that data is transmitted both securely and is presented in a way that applications are expecting. Finally, we reach layer 7, the application layer. This layer is the layer that we interact with directly. An example could be your email client like Outlook, or perhaps even your web browser. The application layer provides network services directly to applications. And this is where protocols such as HTTP for web browsing or SMTP for sending email live. This layer is also responsible for things like application level authentication. For example, when you visit tacobell.com, you log in, the application layer handles the username and password verification. This layer works alongside the presentation layer to ensure data is formatted and presented correctly for applications. For example, it ensures that web pages are displayed correctly in your web browser. From a security perspective, the application layer is where many security vulnerabilities exist. Threat actors or cyber criminals often target applications to gain access to sensitive information or disrupt services. And this is why application security is extremely important. Now, firewalls also exist at this layer, and if we revisit the analogy from layer 3, a firewall operating at this layer would inspect data prior to letting it be delivered using techniques that leave the data intact. Think about it like this, and this would not happen in real life, but the post office opening your packages to ensure that they're safe prior to making the final delivery. In short, the application layer is the layer that you will interact with directly. It provides network services to applications and is a key area for security considerations. Now that we have an understanding of what the OSI model is and why it's important, I'd like to briefly talk about the very similar TCP/IP model. You'll often see the OSI model being used to help teach and understand the intricacies of networking, while the TCP/IP model is the actual protocol suite that's being used on the internet. TCP/IP stands for Transmission Control Protocol, Internet Protocol, and works very similarly to how the OSI model works. While this has fewer layers, you can easily map them to the OSI model, with the physical and data link layer being combined into the network access layer, the network layer being renamed to internet layer, and the session, presentation, and application layer being combined into a single layer called the application layer. However, it is worth noting that all of these layers still perform the same functions even if they're combined. For example, the network access layer is going to handle all of the functions of physical and data link layers, even though they're combined. And with that being said, thank you so much for watching today's video. If you found this video informative or you would like to see more content like this, please consider hitting that subscribe button, and I will see you later. Take care.